Great. So today is, I think, one of the more exciting weeks of the class because we get to start talking about data fetching, which always makes things more interesting. But I also think it introduces some of the more important concepts you're going to come across in this class. And so we're going to, as per usual, first spend the first part of today just talking through these concepts. Some of these are going to be brand new to you and might be also a little bit complicated. So I want to just walk through that and answer any questions you all have on that. And then we'll spend hopefully a good chunk of the second half on putting these into practice in our blog project that we've been working on. And I think there was a couple other questions that people had asked in the Slack to cover. I'll try to cover those as we go through all this, but if there's other questions as well that pop up, just hop in and we'll talk about them. All right, so the first thing I want to talk about is the concept of asynchronous code or async code. And this is like a really important topic, just honestly in programming in general. It's not just React specific in any way. So want to make sure I go through this really well, and hopefully you all can have really get a sense and intuition for how this works. So I think this diagram does honestly a pretty good job of sort of highlighting the differences here. So traditionally, when we think of code, we a lot of times think about synchronous processing. So that's like what's on the left, right? So we do things in sequence, you can think of, right? Like first I will call this function. Then once that's done, I will then call another function. Once that's done, I'll call another function. And so that happens very sequentially, and things wait for the previous line to be done before it executes. So that would be the synchronous process, like you see on the left, right? There's like some process is happening. Here, you can think of it as, for example, like a component. The component calls some function, maybe to do some manipulation of data or something, which we can say happens in process B. It waits for that to be done, and only then does process A, like the component, kind of come back into execution. Now, the alternative kind of setup to this is asynchronous, where you have essentially both processes happening at the same time, so no one has to wait for anyone else, right? So, for example, you could say, hey, a component might say, hey, some function out there, do some data manipulation of some kind, but just do it in the background. Like, and just let me know when you're done with it. In the meantime, I'm gonna go do other stuff. And then at some point, the function might come back and say, hey, I finished the data manipulation work. Here's the result. And then in real time, then the component might say, okay, cool, thanks. And then it takes that and then does something with it, right? For example, like update maybe the UI or something. But the important thing here is, like in this case, what I'm calling process A here, like the component is not waiting for this other process to be done. It sort of frees itself up to do other things in the meanwhile. And this other process will just say, hey, I'm done at some point, and we'll flag it and let the original process know what's going on. So that's a lot of words for these concepts. So I want to pause there. Questions on the kind of high level idea of asynchronous versus synchronous code and processes. Okay, we're going to take that as no questions for now, but let's keep going and talking about why we care about this asynchronous stuff. So as you might have started to think about, one of the big performance, yes, letting it sink in. That's a good call, Brittany. This is very much it takes some time to wrap your head around some of this stuff. So, but one of the main benefits that you might have started to maybe think about is things can be done a lot more efficiently now because now you don't have to wait for each thing to happen in sequence anymore. You can actually have things running in parallel in the background, right? So you can see here a very simple example, right? Like on the left-hand side, you have four pieces of, let's say, code that need to run, and each of them happen in sequence. So you have to wait for the whole time for execution, in this case, 45 seconds. Versus on the right, if you run them asynchronously, so you run them in parallel, the total amount of time is only equal to the longest running task, right? Which in this case is only 20 seconds. So you can start to see a little bit some of the benefits here on performance, uh, in terms of like execution time, but also in terms of being able to do multiple things at the same time, which is really important actually in building performant applications in general. I'll give you another example as well, practically connected to React. So one issue you might notice is, obviously a big part of React is rendering out the UI, right? And so let's say you have a component that's rendering out, right, some UI. And that component, going back to kind of the toy example I was talking about earlier, let's say it asks for some really heavy computation to happen in the background. Now, if you just ran that in a synchronous fashion, right, where everything is happening sort of in sequence, what would happen is the component would say, hey, really heavy function, like go do your thing. But then it would just sit there and wait for that function to complete. So the UI is now stuck. Actually, in some cases, like literally, you would not be able to interact with the UI, like as a user, until it's going to wait until that heavy function is done. And only then does the UI even become like interactable anymore on the screen. So it becomes a really poor user experience. Versus if you run that asynchronously, you say, hey, heavy function, go run asynchronously on a different in this case, a different background thread is how we'd say. So that just runs in the background, but the UI process itself is then freed up to do and interact with the user or make changes or whatever. So this is where it starts to become really important, and we'll see here in a little bit. Like that's where how data fetching kind of fits into all this is you want to run the data fetching in the background and don't block, how we say, you don't want to block the main thread where the UI is running in case, the data fetching takes like a minute or something in the background. Okay, any questions on that or any kind of high level concepts of async stuff before we jump into actually how this looks like in JavaScript? Okay, so I'm going to take that as we can keep powering on. So let's take a look at how this actually works in code. So turns out that all this kind of asynchronous stuff is powered by something called a promise, a JavaScript promise. And it is a way to essentially set all this up for us. So what I've done here is I've kind of laid out kind of the same example written in in a synchronous way on the left and an asynchronous way on the right. And in both cases, you might be able to ascertain this if you kind of look through this code. In both cases, we're just having a function run for 3 seconds, and in the back, just have it run for 3 seconds, and then say I'm done, essentially. So on the left, you can see here we have a use effect, and we're kind of simulating almost like a data fetching here. We have this run sync function. Let me take out my pen. So we have here the use effect. We have this run sync function, which should look like an OR function to you, right? I'm just hacking essentially a way to wait for 3 seconds, to force something to wait for 3 seconds. And after the 3 seconds, I just return some string. And when this string is returned, it then sets the state variable, which then actually is outputted here in this div. Hopefully, you all should feel somewhat comfortable with how this code is set up with recent practice with use effect and state and everything like that. So then the right-hand side is effectively it has the same functionality in terms of you have something that waits for 3 seconds, but it's now set up using an async function. So we still have a use effect, and now we have a function here that's an async function, which you can see because it's tagged as async, and I called it run async. And you can see here, it's a little bit different of a setup now, the way I'm waiting 3 seconds. I'm creating this promise object, and you can see there's this something called a resolve. So essentially what happens here is you're saying, okay, it's a promise, right? And you can think of it like what that term means, right? Essentially, it's like an object which says, I promise you, component, I'm going to return some value. but I'll let you know when I'm ready to do that. And that's exactly what, if we just look down here, this resolve does. Resolve is a special keyword that essentially is a way to say, hey, the promise is going to now notify whoever was taking a look at it that, hey, I'm done. And I'm going to pass back, in this case, this string as a return of this promise. So that's how it signals like, hey, I have a return value that's ready to be thrown back. And then that gets stored in this result variable here. Now you'll notice there's an interesting keyword here called await. This is what essentially forces the JavaScript here to say, wait for this promise to resolve. So wait for this promise to actually return a value to us because it won't happen immediately. And so then it will wait for that. And once it's done, it spits out and stores it in this result variable, which ends up being this fetch data async string. And then we have that value. It's just a string now. So we can still, like usual, set the state variable and it will show up then in the JSX at the bottom. Okay, let me pause there. Questions on the syntax, the idea of a promise, some of the syntax here that we're getting started with. We'll also go into it a little bit more in another example, but any questions on this? Because I know there's a lot, especially a lot of stuff on the right here that's probably highlighted is probably relatively new for you all.
I have a question.
Yes,
For a sync component, could you explain what's the last part, the result?
yes. So, and I did gloss over this a little bit, but what I've done here inside the use effect is I first just defined the function here, run sync, but I haven't called it, right? So then all I'm doing is I'm saying, okay, I've defined the function. Now let me actually call the function and get the result from the function, and then I'll set the state. So it's just a matter of I have to actually call the function for it to do something. Because up until that point, just defining what the function is. And you'll see some similar here on the right. I define the function first up top in the use effect, but then I have to call it at the bottom here, run async, right? So it's just calling the function. Can you use some analogy to explain? Yes. So what an interesting analogy would be. So I think one analogy for all of this could be cooking food, right? So let's say that you are making a pasta dish as an example, right? So if you were to make the pasta sink, and let's say in this pasta you have some pasta, you gotta boil the pasta, you got to maybe you're gonna stir fry it with some vegetables or something, right? Put some sauce in it, whatever. So if you were this, just as a really extreme example, let's say you were to run that cooking process in a synchronous way. The way you would do it is you would say, okay, first I'm going to take the dry pasta. Then I'm going to boil a pot of water and put the pasta in there. But then I'm just going to wait. I'm going to wait until that pasta is boiled. I'm not going to do anything else. Only then, after that pasta is boiled, I'm going to take it out. And only then am I going to cut the vegetables. And then once I'm done cutting the vegetables, I will put that in the pan with the pasta. I'll cook it. But again, I'm going to wait until all that is cooked. And only then maybe I'll create some sauce. And then the sauce I'll put in the pasta in the pan. And then everything will be done. Now, the main issue there, as probably if any of you have cooked, is that's like highly inefficient, right? Because you want to, as the pasta is boiling, you're probably cooking the vegetables at the same time. Because why would I wait for the pasta just sitting in the pot, right? So then the asynchronous way would be exactly that. Like, okay, I put the pasta in the hot water, it's boiling, great. As that's going, I'm going to be cutting vegetables over here. I can do that in parallel. At some point, I'll know that the pasta is, going to be done and boiled. Now, maybe a timer will go off. And once the timer is off, I can say, okay, then I can take that pasta and put it in the pan. And then pretty quickly at the same time, I put the vegetables in the pan. Right. So everything becomes much, much more efficient. I'm not just standing there doing nothing at any given point, right? I'm always doing something. So that's a very maybe hopefully illustrative example of sort of like how all this is kind of working. Hopefully that helped. All right. Any other questions on the promise structure? We'll talk about one other element of the promise as well here in a second, but any questions on anything on this screen? All right. And let's keep powering on. Let me clear all this. So I think the good news I would say is that in most cases, actually, you won't necessarily need to write out like await new promise and then do all this stuff. Because a lot of times certain functions that come in JavaScript are already asynchronous for you. So they are inside those functions, they are already returning a promise actually, and you just need to know how to handle the promises. So there's two different ways you can handle a promise. And one of them we just saw, and there's another way. So the first way is to use this await keyword that I mentioned on the previous slide. And so that's this word here that I've just boxed. And this is essentially a way to say, hey, in this case, right, const post data equals await get post. And what that is saying is let the get post function finish resolving. Let that assume that function returns a promise. So let that promise resolve, let it return the actual post data, and then I will set that to the post data variable. And now it's just a regular JavaScript object with the post data. That's it. And then I can go and use it like a normal object. The reason that's important is let's say I did not put await. Let's just say I said const post data equals get post. The problem is the return type of get post is actually the promise. It's not the actual data. So it's a promise saying, I promise to give you this data, but it's not the actual data. So you would get some weird results where now the post data variable is actually a promise. It's not the actual data. And so if you try to kind of go forward, there'd be a bunch of errors essentially being like, hey, you have an unresolved promise. You just have this promise, but you haven't resolved it in any way. So the await keyword here makes sure that, hey, first let the promise resolve, get the result of that promise, and then store it in the variable and then proceed on as usual. So that's the first way. The second way you can handle the promise is on the right here, which is forget the await, call the function, get post, and then you can start training other functions on top of it as handlers. So for example, we could say, once get post resolves, then with this dot then, and then you put a function here where the input of the function is whatever the data that's being returned from the promise, and then do whatever you want. And then you also have, similar to the left-hand side, which I glossed over, is you can also then catch any errors that the promise might throw and do whatever you need to do. So hopefully you'll see, like, for example, what I'm actually doing with the data, which in this case is calling set post, is the same on the left and the right hand side, or what I'm doing with the errors, which is just consoling the errors, is the same. But these are just different syntaxes for how to manage promises. Which one is better? It's very much personal preference. I personally like using the await keyword stuff on the left because like it looks cleaner to me because I can read it top to bottom and it still reads kind of like synchronous code. So that's my personal preference is to go with the await keyword, but the kind of chaining on the right hand side is also perfectly valid. Both things do exactly the same thing. Questions on these two ways of dealing with promises?
Yeah, I have a quick one. So Ari a line of code that references post data that is awaiting it, that those lines of code won't run. They'll also be awaiting for post data to resolve.
Yeah, yeah, exactly. So, and that's a great point. So let me get my pen again. So what Melissa is calling out here is, so we're saying const post data equals await get post data, but then we have all this other line here in this case, right? The set post. So yes, that will not run until the promise resolves. And that is by design here, right? Because if it didn't resolve, we would be setting post to like a promise here, not the actual data. But yes, what await does is essentially says stop the code execution until this promise resolves, and then we'll proceed.
Okay, thank you.
Yep. And I think to be also super clear about that, how that relates to what I was talking about earlier, where because you might say, well, at the beginning you were like, you were talking about like this stuff is being done in parallel. So why is it blocking? Why is it essentially you're just stopping the code again? But the idea is this code block, it's stopping execution in this code block, but it's not stopping execution globally in the component. If you were to run this synchronously instead of asynchronously, the problem here would be this get post function, let's say, is like takes like 20 seconds or something. If you wrote this synchronously, it would block everything else in the application for 20 seconds. In this case, it would just block this portion of code for 20 seconds. So that's the key difference, right? Is we might still want some blocking functionality because some things it still needs to be done in sequence here in this case, right? Like I need to first get the post data before I set the state, but it's not blocking the rest of the application. That has nothing to do with this, right? So that's the key difference here and the power of using these kind of asynchronous patterns. Which method is faster? So both of these like both of the ways of writing the code here are exactly the same behind the scenes. It's purely just how you actually write. It's just purely syntax at this point. But both of them do exactly the same thing behind the scenes. Because, okay, we just kind of walk through the left-hand side. So the right-hand side, the way you would read this is, okay, you're calling get post, and then you're essentially saying like, hey, when get post is done, then set post, right? So it's exactly the same thing as what we just said on the left hand side. It's just written in a different way on the right. So as I said, it's kind of personal preference in terms of stylistically, like which way you want to write and deal with promises. You could say the right hand side code it looks a little bit shorter, or the left. Again, in my opinion, I think the left hand side is more readable, if just top to bottom. But everyone's got their own opinion on this. Any other questions on dealing with promises? Where does get post come from? Yes, so the assumption here is there is some function defined somewhere called get post that returns a promise and would return a promise that would resolve to some post data. So yeah, that's the assumption here is that that function exists somewhere else that not written. And as we'll see in a second, you could maybe say like, hey, that's some function that does some data fetching maybe to some remote data source or something. All right. If there's no other questions, let us keep going with an example. So let's say we have this simple component. We have the state where we're storing the list of recipes, and I'm just going to map and return out these recipes into some recipe card component. But I actually want to get the list of recipes by calling some get. Let's assume there's some get recipes function we can call it that returns a promise. So we need to actually do that and pass it through to the state variable. So how would we go about doing that? Does anyone have any ideas of where we might want to start with this?
So you write it already. To do get the list of recipe from async get recipe function. So yeah, we
Yes.
use effect first. Yes. So we need to get the list first.
Yep. I think you were just starting to say that, and then Brittany also said we need to use effect. And then inside that use effect, what would we want to do?
We call the API.
Yep. And how exactly would we? Let's assume the function is called get recipes. Like what would be the code that you would write?
Or maybe we define the async function to get recipe, like some.
Yep. So that's a good start.
So we maybe write here async function name function, and then we use that function put we put in the use effect later.
Yep. Great. And then what else? Is there anything else that we need to do besides just calling the function?
Okay. Maybe we need to import the use effect. No. Okay.
Yep. No, you're on the right track. Specify a weight. Yep. So that's a good call for that. We will need to specify a weight here if we're going to use that approach for calling the function. And then there's one final thing that we'll just need to do after we call the function, which maybe it's too obvious and that you all are not saying it out loud, but just to be explicit, there's one final thing we need to do to make sure that this data is actually like showing up in the UI. We don't need to worry about the promise anymore, actually. So this is like after we've called it, there's one other step we just need to do. Hint maybe has something to do with the fact we have some state. Yep, update. Exactly. So we just need to update the state. So yeah, so hopefully this was meant to be a relatively straight, simpler example, but exactly as you all were saying, we assume this get recipes function exists somewhere. We just need to await this function and store the response, and then just update the state with that response. And of course, in the actual situation, as we'll see here shortly, there's obviously some assumptions here. I'm simplifying, like the shape of the object that's being returned by the function is exactly the same shape we need in the state, so we can just set it directly. In some cases, you might need to do some data transformation before you do that translation. So again, I think the key things here, I would say, are just kind of concept of we have an async function. We need to use something like await to make sure we kind of get that data back. Or you could also use the other kind of structure we mentioned earlier using .then and .catch. We're going to get the response and store it in a variable, and then we can do whatever we need with the variable. So in this case, we can just update the state with that. Can we declare await without the async? No. So you can only use await when you are dealing with an async function. Oh, I see what you're saying. Yes. So You are correct, Anthony. Technically, actually, this code would not work because if we just go back, and this is a good point. So if we go back to this example, a really important rule is, and React will complain if you try to do this. If you call await, you have to call await inside of some async function. So that's actually why here in this case, we actually define a function here in the use effect because we need to declare that as async because only inside of that can we even call await in the first place. So technically speaking, the code that was there, if I kind of click forward, this actually technically wouldn't run. The way you would also need to wrap essentially this inside of a function and declare it as async, so we can call await, and then you can call that function inside the user. So that is a good call, very good call. And as I said, like if you try to do this, like your code will like scream at you with like big red arrows being like, yo, this is bad, you can't do this. All right, any other questions on this example? And I'll actually be sure to just update this slide as well before I post it for you all. So this is updated correctly. All right, so let's keep moving. So we talked about async. We're starting to wrap our heads around this kind of new idea that probably seems a little bit weird at first. But now let's actually do something interesting with this concept, and that is actually fetch some data, which is honestly one of pretty much the main way that async is used in building applications. Not the only way, but the most common way is with data fetching. So typically, there is like a certain structure to how data fetching happens in an application. Okay, let me get to Anthony's questions real quick. Does the async use the same CPU that the other is using? So yeah, so behind the scenes, the way it works is it's on, well, I think your computer was only gonna have one CPU, but pretty much every modern CPU nowadays has multiple threads, right? So these are multi-threaded systems. So what async will do is the asynchronous function is running on a different thread than the main thread. Hence why you get all the performance benefits of running things in parallel. Yep. That's a good question. Okay, so data fetching. So I would say there's some pretty standard ways that data fetching is done in React, right? So first thing is a lot of times this data fetching involves needing some data source by an API. So we need to do some fetching of some remote data service. This will use the fetch call that comes built in to JavaScript, and we need to run them inside of a use effect. Because I think as we talked about use effect last week, because this fetching has nothing to do with actually rendering the UI, we have to throw it inside of a use effect. Otherwise, that's the only place you have to make sure it runs. So we can run inside the use effect. Typically, the way it would work is you would run it on initial component mount. So you would have a use effect with empty dependency array to have it just run on component mount. As you might guess, this should be done asynchronously so it doesn't block the rest of the application. And the other thing to call out is some APIs, depending on what you use, they might require some additional options like some sort of authorization token because they don't want some random person calling the API because of sensitive information, or some other things as well that you might need to pass in. Maybe some parameters for whatever you're trying to fetch, for example, or something that you're trying to update or something on some data service. So this code on the right-hand side, I think, is a great example, kind of a typical data fetching structure. So let's just quickly take a look through this. So you'll see we have some state variable here that's going to set, let's say in this case, some profile data, let's say user profile data. We have this big function that we are defining, and then we're just calling the function here at the very end. And again, the reason why we need to do this is because this is being tagged as an async function. So we have to, you might say, oh, maybe we could just stick async like right here inside the use effect and define like the execution code as async. You can't, like that's a restriction on use effect. So that's why we have to like do all these gymnastics of defining a separate function inside the use effect that is async, throwing all the async code in there, and then calling that function at the very end. So we have this async function. Inside this function, we are using a try block because a lot of times with the data fetching, you have to handle errors correctly. So we're going to do a try block. We're going to use the await syntax in this case, using the fetch function. We'll typically try to hit some URL of some kind. We then can pass these options for the API call. So typically you would pass first like a method. So are you trying to get something from the API? You're trying to put something in the API? You're trying to update something, delete something. So there's the kind of different methods which are pretty standardized. Then these headers are sort of additional options that you might need to pass in. So for example, in this case, I have added sort of an example like authorization token that we might need. And this is sort of the syntax of what that looks like. And we'll get into that a little bit more and what some of this like import.meta.env stuff is. And then content type, in this case, you actually don't need it, but this would be if we need to pass some data in. And typically you pass some additional information in as a JSON object, so you just specify that in the header. So that is the actual fetching. After the fetch resolves, after that promise resolves, we first will typically check if the response has an OK status. If it doesn't, we're going to throw an error. Otherwise, we keep going. We will extract the JSON from the response object using this await.json function. And notice that this is also a promise here, so we have to await it. And then we can do, in this case, we're just going to update the state with that data. And then finally, we have this catch block here that will catch any of the errors that are thrown in the try block. And in this case, I'm just going to console the errors out, but you could do obviously other stuff as well. And yeah, so that's overall kind of a very high level, pretty holistic example of sort of how the data fetching patterns would work in React. Questions on any of that or anything that you would like me to repeat? And maybe one thing I'll point out here, but listen, you had sent some questions earlier. So I think one of these questions we can probably handle here. So I think one of your questions was about you had tried to do this before. I think you had said that you had moved some of these definitions of certain things like the authorization token outside, and that the use effect was complaining that you have to add those to the dependency array. That is because ultimately it comes down to actually how use effect is working, right? Because you're defining a variable outside the use effect, that variable could change value. And so hence use effect is saying, oh, you're using a variable here that could change value. Therefore, you have to declare that as a dependency. The way you get around that is, I think as you had found out, is you can just do that definition inside the use effect, like this example here. And that way it's sort of all self-contained inside the use effect. There's another way to do it, which is actually, I'll show this in a little bit. My preferred structure for all this actually is just take this entire like fetch profile function and don't define it inside the use effect, but define it outside the use effect altogether. And then just like call the fetch inside the use effect. And in that case, it's sort of all those authorization tokens, everything are sort of abstracted away from the use effect. And so it also won't complain at that point. But I'll show an example of that as well in a little bit.
Thank you. Okay, that makes sense.
Yeah. Yeah, you are dealing with the very nice nuances of React at that point and use effects and everything. What's the difference between the two errors? So in this case, there's only one error here, right? So to be super clear, let me switch colors. Blue. So the only error that's actually being thrown is this error here in the blue, right? This is where I'm saying like throw new error and then the error. This down here is a catch for any errors that happen. So once you throw the error, just as a standard try catch block in JavaScript, once the error is thrown, it just ignores everything else below in the try block and just goes directly to this catch block and passes this error in. And then in this case, I decide I just want to console out the error, right? So there's only one error here that's being thrown. And then there's just the catch block, which is saying like, okay, you've thrown the error. Like, what do you want me to do with it now? All right. Any other questions on sort of this overall structure of how we do data fetching? All right, let's keep moving then. So one part of working with remote data is the actual syntax of data fetching. The other part is just figuring out what the data is actually and what actually you care about and how these APIs actually are responding to your requests. And this is surprisingly like actually can sometimes be even more tedious than actually just writing the code. So here are just some general pointers I would give for working with APIs in general. And to be honest, all this stuff is not even specific to React. This is just in general dealing with remote APIs in any sort of application. The first thing is a good API should have good documentation. And so a lot of times in those documentations, they will give you essentially what the request should look like and what the response will look like to the request. So you can see here on the right-hand side, I took a screenshot of like the Airtable API documentation, which is actually pretty good, I would say. So as you are working through your assignment for this week, trying to work with the Airtable API, feel free to take a look at documentation because that might help give you a sense for how to be working with the actual data and what data is it giving back and what structure and therefore how should I be dealing with it. The second thing is maybe you don't want to read a bunch of docs, which is fine. I also am not a big fan of reading long docs. So another way you can sort of explore APIs is you can kind of trigger them manually outside of an application. So there's some great, you can do it from the terminal if you want, but there's also some great applications out there. I've listed some here like Yak, Insomnia, Postman. They are great API testing tools. And I'll actually show an example of this here when we do an example. So this can be a really nice way also of like quickly testing APIs and getting a sense for what the response looks like and therefore how to work with it. And the final thing I'm going to say is, and this is really, really important, a lot of times these APIs do require some sort of authorization, as we talked about, right? Because whether it's because, let's say you're working with an API that like has some payment. Like for example, let's say you wanted to use an OpenAI model for something. They want to know who you are so that they can charge you for the API call for the LLM. Just as an example, or it could be because it's sensitive information. So you want to secure that connection, make sure only certain people can call the API. Those API keys, I just want to say this very explicitly, should never, ever be committed to your repository code, ever, because those should be treated like passwords. As soon as it's committed somewhere off of your system, you should consider it compromised at some point. And that's a problem because now someone else can just take your API key and use it, and they can either run up your bill or they can access data they're not supposed to have access to. So the structure around that, how you get around that is through something called environment variables, which are sort of injected into like when you spin up a server let's say like when you run npm run dev, the way the environment variables work is they're not stored in code, but they're actually injected into the server runtime when you start the server up, and then the code just accesses them blindly. So that's where, just to go back here, you have this import.meta.env.beat API token. That's sort of that's a way to say, hey, access the environment variable called beat API token in this case. So without having to manually hardcode actually what that value is. So it is actually protected from the code, and then you just never ever commit that. Typically that happens in a .env file. You just never commit that code up into a repository, because that's like one of the simplest ways to get like a big security risk. So I just want to be that really explicit because it's like really, really important. Questions on any of this? Or I think we jump in, yeah, into some live coding for the last 10 minutes. Cool. So let's then hop into some live coding. Let me share my screen here. Can you show how to store auth tokens? Yes. So I will show an example of that. Cool. Okay, so I have the repository open for our React blog. Hopefully you'll recognize this by now, for those of you who've been here in the past. And I had a list of things that we could do. I know we only have 10 minutes, so let's see how far we get. We'll pick this back up next week or in the next session. So the first thing that I was talking about was environment variables. So if I open up the folder structure, you'll see I've added here a file called .env, where my cursor is. Now I'm not going to open that file because it has some tokens in there. And as I said, you got to keep them secret. So that is not committed at all to the repository. And to show you that, what I've done is I've gone to the .gitignore file, which you all have in your projects by default, and it's pre-filled with some stuff. And I've added .env as a file that should be excluded from Git. Git should not be, it should be as if that file doesn't exist to Git. So it should never be tracked or committed at all to the repository. Now, most cases in like modern code bases, this is like always going to be part of the .gitignore. For some reason, Vite by default does not include it. I actually don't know why. They should. But you'll need to add this to your project at the beginning, and so that this file is never committed to the repository. Now, what that means is, let's say I delete this whole project and I have to reclone the repository. I won't have the .env file anymore. So I would need to recreate it with the tokens and get the values again. But that's seen as being a fine trade-off because those keys are so sensitive in a lot of cases. Now, something that is helpful to have, which I think is a really good idea, is something called a .env.example file. So I can open that one up. And what I just show here is, here are the variables that you need for this project to run, but without any values attached to them. So this is a really good reference because now if I clone the repository, and this is part of the repository, this is totally safe. When I need to create a .env file, I can just copy this, I can duplicate this file because it has all the variable names already pre-filled. And now I just need to go and set these values to whatever they need to be afterwards. So this is a nice convenience thing that I think is nice to have, is sort of this .env.example file as at least a reference to like what variables do I need to run this code. And again, as you be really explicit here, I've not included .env.example here in the gitignore, so this will be committed to the repository, and that's totally fine because again, this is just the variable names, not the actual values themselves. Questions on that setup? Great. Okay. So close these files. Now, let's just do, maybe we'll probably have time for one example of sort of the data fetching. So something that I thought would be kind of cool is, I think maybe you all realized on GitHub, when you have a repository, you can star the repository. And that's for public repository, it's public information, how many stars that repository has. Sort of as a nice indication of like how popular that repository is. So as you might know, React is a public open source project with a GitHub that is public. And therefore, we could get how many stars that repository has, the React database has, the React code base has. And it turns out GitHub has a nice API to get that information. So to explore this, I have one of those API testing tools I talked about called, this one I have is Yak. And here what I've done is, I'll just make this bigger. At the top here, you can see I'm calling a GET request. I have pasted the URL of the API in this case, api.github.com/repos, and then this is the repository is Facebook React. If I need to, I could add headers, for example, authorization tokens or other parameters. In this case, I don't need to. And then I just run it. And you can see here on the right, this is the response that comes back. And you can see this is a very big object that comes back. But this is really nice because now I can actually look through here and see like, what do I actually care about? And if I scroll down enough, I will see I care about watchers count. And so there's 234,965 people who've started this repository right there. So this is really good because now I know exactly what I need to look for. I need to get the response object, and I want this property specifically off the response object. So I think this is like a nice way to kind of explore the API before I write any code. Cool. So with that in mind, I've already started pre-filling some of this code for us, so it's a little bit more efficient. But let's see. So what I'm going to do is, let's say I want to add the number of stars that the React repository has and just add it here in the header for now. So I'm going to the header component that we have. And I'm first really simply going to set up a state variable for the value. And let's just set it by default to 0. And then let me just add this simple p tag here where I just GitHub stars and then the value React stars. So if I try that, it's just going to say GitHub stars 0. Cool. Not very fun, but it works. Now we want to fetch this data. Now, as I mentioned briefly earlier, my preferred way of structuring this fetching code is I define the actual like async function for fetching just like separately. And then I create the use effect with the empty dependency array and just call that function. That way it's just very clean at least when I look at it, it just looks much cleaner. So what do I do here, right? So I call fetch React stars. It's an async function. I have a try catch block because I want to handle errors correctly. Inside the try block, I'm going to await fetch that same URL that we just looked at. And I'm just going to tell it, hey, this needs to be a GET request. I don't need to pass any headers in because I don't need to authorize. So I get the response and I await it. I then check if the response is not okay. I throw an error, and then that error will pop down to this catch block if it needs to. If it is okay, then I keep going. I will await the JSON of the data that's come back in the response, store that in data. And now this data object corresponds to this response that we saw on the right-hand side here in this panel. But I know we specifically cared about this stargazers count value in the JSON. So I can just extract that part out and then update the state with that value. And so now, just to be super clear about this, if I refresh the page, okay, there you go. You can see the number is now popping up here from the remote API. Questions on that structure and flow? Great. So one thing I just want to show here that's kind of interesting is I'm going to go and I'm going to artificially slow down the network requests by putting a throttle on the network so I can make this like slow 4G. And this is a really cool tool, actually. And pretty much all the browsers have this. So I can simulate as if I'm on a really slow internet connection. So if I now refresh the page, and if we just watch this page load in, obviously it's much slower. But let's see, this is going to load. Okay, you'll notice for a split second, you might have seen that GitHub stars, it was just blank, right? And then this 2349655 number just popped in. And that's because the data request in the background took longer because we're simulating a slower internet connection. So something that's sometimes good is to put some sort of loading state as the data is loading, so it doesn't just flash. Now, one option could just be, just don't even show this paragraph if there's no data. So that's the simplest way. So you'll notice by default, I've set React stars, the state variable, to null. So I could just say, I could use conditional rendering here. So I could say, if React stars is some value, then I can actually have this p tag. Otherwise, we just show nothing. So now if we go back and refresh, loads in. Now you'll see here, the whole thing wasn't there for a second. And then once the data came back, it actually loaded in the whole component. This is just one option for how you might want to handle this. You could just say GitHub stars fetching instead, if you didn't want to just remove the whole thing. So there's a lot of different ways you could do this. But that's another really important part is sort of this idea of having a loading state, right, for the data fetching and handling that in some way. Any questions on that? I know we're at time, so I'm going to probably will tackle the rest of this stuff next week. All right. If there's no questions, you all are free to go. We are at time, but I'll stick around as well if there's any other questions that folks want to ask about. Have a good rest of the weekend, and I'll see you all later this week for the next session.